All right, here we go.
So gonna be a lag.
All right, there's gonna be a little bit of a lag. All right, here we go. All right, so rewrite the following degrees in radians or radians to degrees. What I want to see from this is pretty much your knowledge of 5 pi over 6. Multiply that by 180 over pi. That's it, okay? So cancel. You could cancel this at 30. So this will be 150 degrees. All right. Yeah, you can use the unit circle as well. Yes. I would like for you to at least show it once. Like maybe for A, you don't have to do it, but for like B or C, like convert radians to degrees and degrees to radians once. Okay. Thanks, Jared. All right. Number 2, 660. You can subtract 360 from this and then get 300, or you could multiply that by what, pi over 180 degrees. So cancel, and then it'll be what, 33 over 9, and then it'll be 11 over 3. So 11 pi over 3. All right, and that's your answer. Actually, don't subtract 360. Just give me the 11 pi over 3. I think that'll be better because that's more on the accurate side. It's actually 660 degrees. All right. All right, here we go. And then letter C is negative 15 pi over 4. Multiply this by 180 over pi. Cancel. 4 goes into 180 how many times? What, 4? Be 5 times. So negative 15 times 45. Anybody get that? Thank you. You could do that. That's fine too. That's fine because remember it's going around just one more time. This is the 11 pi over 3 is going over one more time. So if you put 5 pi over 3, that's fine too. Right? Any questions, or just show me that you know how to convert this. Okay, so right. Number 2 is find one angle with positive measures. So if you go to the unit circle here, we go to the unit circle. So slow right now because let me stop sharing. Go to the unit circle right here, right? You're just trying to find another angle that will stop right here at 30 degrees. Okay. All right. So you're just trying to see which angle will stop at 30 degrees. All right. So if you go around 360 one time, right, it would be what? Oh, you guys can see it. Sorry. If you go around 360 degrees right here, starting at the 30 degrees, what would it be? It would be what? If I 390, right? If I went around, it would be 390. What if I go this way right here?
330.
Maybe negative 330. Okay, so it's either you can write 390, comma, negative 330. All right, and it'll land on the same spot right here. Okay, all right, but don't be so like automated about the add and subtract thing. Okay, like letter B to it, it's okay because 135. If you add 360, what's 360 plus 135? That's 495, right? You subtract it, what would that be? Negative 230, sorry, 225, right? So negative 225, you could do that, okay? But let's look at letter C, okay? Let's look at letter C here. So letter C would be at 90 degrees, right? Because here, if I go one full revolution, that's 360, and then I ended up at 90, right? Because this is so you can just write 90 degrees here. You can add 360 if you want. 810 would be the same thing, right? But the tricky thing is you have to get a negative number for this too. So I would start here. If you go this way, right, this would be negative 270. Okay, so just know what you're doing. I mean, don't just automatically go, okay, I add 360 to subtract 360. Like, don't just do that, but know like the why behind it. Okay, so we all land in the same spot here. So you're trying to find a negative value and a positive value that will land in the same spot. Cool, right? Not too bad, right? Number 3 here is when you start getting points like this, all right, you're going to have to get out of the unit circle a little bit, all right? And so when you do this, you have 3, 1, 2, 3, and a -4, 1, 2, 3, 4. And here's our dot right here, right? We go this route right here. Okay, so if this is our angle, theta, if our reference angle right there, all right, that means that this is 3 and this is -4. I'm going to use a lot of Pythagorean triples, 3 numbers that go into the Pythagorean theorem. Okay, so this 3 squared plus 4 squared equals c squared. So this is going to be 5. Okay, so if we did the Pythagorean theorem, I'm going to skip that step right now, but if we did the Pythagorean theorem, that hypotenuse would be 5, right? So then what happens? If I get the sine of theta, that's what? Opposite over hypotenuse, or opposite over radius, which is equal to what? What's the opposite? What is it? -4 over 5. Okay. What is the cosine of theta? We what? What's the opposite? Oh, what's the adjacent? 3 over 5. You guys have to remember your right triangle trig, right? Your tangent is what? -4 over 3. Everybody understand that? So we did the Pythagorean theorem. That's how I got the 5. All right. 3 squared plus 4 squared is equal to c squared, or r squared. I should put r. All right. That's 9 plus 16 is equal to r squared. So r is equal to 5. That's how I got the 5 here. Okay. All right. Everybody good there? So now it's pretty easy, right? Because once you get the cosecant of theta, you just have to flip the numbers over. So -5 over 4, right? Secant theta is 5 over 3. And then cotangent of theta is equal to -3 over 4. Any questions on that? So hopefully you're able to do letter B. Letter B isn't too bad, right? Letter B is, you guys need to go over this one, or are you good? Remember, sine is opposite over hypotenuse, or opposite over radius in this one. The theta is right here, right? The theta is right here. Opposite, which is 4, over hypotenuse, which is 5. Okay. Cosine's adjacent over hypotenuse or radius, right? Tangent is -4, opposite over adjacent. Right, so if I do -20 over -21, that's going to be in quadrant 3. So -20 is right here. Right, -21 is right here. So our x is 20, -20, our y is -21. So if we do this in the Pythagorean theorem, 20 squared plus 21 squared, and get the square root of that, what does that equal to? What was the Pythagorean triple? It was 29. Okay, so if you do the Pythagorean theorem, this is going to be 29. All right. So from here, sine of theta would be what? -21 over 29. Everybody get that? Any questions on that? That's not too bad, right? Okay. Cosine of theta is what? -20 over 29, right? What should we call it? Tangent of theta? -21 over -20, which is equal to 21 over 20. Right? They both turn positive, right? All right. And then what? Cosecant theta is just a reciprocal. That makes it easy. So you just really have to know like the relationship between secant and cosine, and sine and cosecant. Okay. All right. Are we good? All right. Any questions on this? All right. Do you need more time to copy, or are you good? You need more time? Okay. All right, here we go. All right, we'll find the reference angle with the given measure. All right, so remember that you're trying to find the angle that is closest to the x-axis. All right, so 645, this whole thing right here is 360, so we know that it's already 360, right? Then if we go over another 180, that is 540, right? If we go another 90 degrees, that's 630 right here, right? So what, 645, we have to go another, what, 15 degrees here, right? And we find an angle here. You guys see that? So now we have to figure out what's the angle that's closest to the x-axis. So what would this angle be right here? What would it be? 75, right? Because you just pretty much subtract 90 to 15 and you get 75 degrees. So this, the reference angle would be 75 degrees. All right. All right. What about 532? 532 again, let's do it a different chart. It's negative. So negative, this is what? Negative 360 right here, right? And then what? Negative 540 right here, right? If it lands here, negative 540. So 532 would be like right here, right? Right? So what would the reference angle be right here? This would be 8 degrees. Good job. Okay, the reference angle is always positive, all right? Now, why do you have a reference angle? Like, why do we need that, all right? What's the purpose of that? Well, let's say this. Let's say we land, like we go a few times, right? And then we land right here. And this is like, this right here is 30 degrees. Okay. Then we kind of know that, hey, we know that the x value be radical 3/2 and the y value be 1/2. It just depends on what's negative and what's positive. So the reference angle kind of tells us whether we should use a 30, 60, 90 triangle or the 45, 45, 90 degree triangle. Okay, so it's just kind of a helpful tool for you to understand. All right, so anything that kind of like is closest to the x-axis, that's where you kind of it'll help you understand that. Cool. All right, number 5 is pretty straightforward. You could just look at your chart. Okay, so that one is negative radical 3/2, right? If you look in your chart, you should be able to see that the sign of 5 pi over 3 is negative radical 3/2. A lot of people have trouble with fractions. So just keep in mind what this is. This is what, 20/3. You're not going around 20 times. Okay, it's 20/3, which is what? 6 2/3, right? 6 2/3, and then pi. So if you go 6 pi is what? 1, 2, right? And then 3 times, right? Right here. And then 2/3 would be what? Not like right here. All right. So you have to get pretty much the tangent of 2 pi over 3. 2 pi over 3 tangent is what? That is sine over cosine. So it'd be radical 3/2 over 1/2. And it's negative. The x is negative. So to get the reciprocal of that, of the 1/2, and that is just negative radical 3. You can also just look in your chart too. All right. Secant of negative 19/4. Negative 19/4. Put that in a mixed number. That's what? 4 3/4 pi. So 4 pi is 2 revolutions around the unit circle, right? 3 pi over 4 is right here. So this is at what? 135. So our what's our secant? So if we want secant, we have to get cosine. So 1 over cosine. Cosine is negative, so it'll be 1 over radical 2/2, which is 2 over radical 2, multiply top and bottom. So it would be just radical 2. And we're talking about cosine, so this is negative radical 2. All right. Any questions on that? We good? Not so bad, right? I mean, are you guys kind of getting this a little bit? Good. All right, number 6. All right, we kind of have to chug along here a little bit. Here we go. This is 16. Opposite is 16. Adjacent is 12. 20 is the hypotenuse. Okay, so I forgot to mention this is in Q1 and this is in Q4. All right, so sine theta is very similar to the ones before, is 16 over 20, and just simplify to 4 over 5. You need to simplify. Cosine of theta is equal to 12 over 20, which is equal to what, 3 over 5? Tangent theta is equal to 16 over 12. That's what we already got, so that'll be 4 over 3. All right. And then flip it over. So cosecant theta is 5 over 4. Secant theta is equal to 5 over 3. And cotangent theta is 3 over 4.
Jay,
Yeah.
how do you know where the values on that chart?
I should have put Q1 and Q4.
No, not that two, but on the triangle, you have like the opposite. of the adjacent.
Yeah. So here's the angle right here, right? That's why this is the opposite, this is the adjacent. It could have been also on this side. It could have been on Q3 as well, right? Because a negative divided by negative is positive, right? It could have been on that, but so on the test, it'll be specific as to which quadrant it will be on. Okay. So let me move along and then we'll answer questions after the recording's done, okay? Sine sine of theta is right here. Oops. -9 and 15, so -9. So it's in Q4. I should have mentioned to you it's in Q4. So 9 is right here. 15 is the, hold on a second. Now 15 is the hypotenuse, right? Sorry, 9 is right here. 15 is right here. That's the opposite, right? Opposite over hypotenuse. So that means that what? 12 is right here. All right, so the cosine, the x value is 12. All right. So our sine value, this is -9. So our sine theta is equal to -9 over 15. Cosine theta is equal to 12 over 15. It's positive. Tangent of theta is equal to -9 over 12. If you simplify, make sure you simplify -3 over 5, 4 over 5, -3 over 4. And then the cosecant theta is equal to -5 over 3. Secant theta is 5 over 4, and cotangent theta is equal to -4 over 3. All right, cool. Number 7, here we go. Number 7, let's keep going along. Whew. All right, we're only like halfway through the test, but I think we could go faster because of the graphs. The graphs should be a little bit better. Cosecant, if cosine is -3 over 2 and sine is is positive, okay? So let's look at the unit circle. So cosine is negative radical 3 over 2. So it's either going to be 5 pi over 6 or 7 pi over 6, because that's where the x value is negative radical 3 over 2. But we remember that the sine is greater than 0, so it has to be here. So we have to go what? We have to go to the values here of 150. All right. So the values of 150 are what? It was negative radical 3 over 2, comma 1/2, right? And so the cosecant theta is equal to 1 over sine theta. Sine theta, right, is equal to what? What's sine equal to? 1/2. So this is equal to what? 1 over 1/2, which then equals 2. All right. Let me give me a second. I forgot to share that screen over there. So all right, and then letter B is find the secant and cosecant. Tangent is 9 over 40. So 9 over 40, and the sine is less than 0. So if the tangent is positive, right, there's no negative, and the sine is less than 0, we're probably at Q3 right here, right? So opposite would be 9, 9, and then the adjacent would be 40. So what's our, so if you do the Pythagorean theorem, it'd be 41. So both the sine and the cosine would be negative. So our secant is 1 over cosine, right? That's what secant is equal to. And the cosecant is 1 over sine. Okay, so cosine is what? Cosine theta is equal to negative 40 over 41. That means that secant theta is equal to 41 over 40, or negative 41 over 40. Sine is negative 9 over 41. So that means that cosecant theta is equal to negative 41 over 9. We good? So you kind of have to just manage the stipulations and the parameters and then go from there and attack it from there. All right. Number 8 is pretty fast. Remember it was A sine B and then X plus C minus D. Remember that formula? Or it's actually, wait, sorry, it's plus and then minus, right? My bad. Okay. So the A is the amplitude, the B is tells us the period. It's not the period, but it affects the period. The C is the shift to the right, the D is shift up or down. So the final answer is 4 cosine, because we're looking for the cosine function, 1/2 x minus 4 minus 3. How did I get 1/2? Because remember, it's 2 pi over b is equal to the period. If the period is 4 pi, two divided by what number equals 4? And so it has to be 2 pi over 1/2. That would equal the 4 pi. Okay. Someone asked me too today, if I put the 1/2 inside the parentheses, would I get it right? You would, but you have to make sure that if you put the 1/2 x, the 4 has to become the 8, because remember, you're factoring it out. So you have to do this if you want to leave it inside. Okay, so just be mindful of that. You're pulling out 1/2. You're supposed to pull out the 1/2, so be aware. All right. We're good. Okay. All right, I know we're going along, but let's try to hang in there with me. All right. Number 4. Oh, no, it's number 9. Okay, so I'm not really looking for a specific answer here. I just want to see like how much you are thinking about it. Okay. So notice that this graph, this is called the midline right here. Okay, and the midline got shifted up 5 times, right? Is this wave a sine wave or a cosine wave?
Sines.
It's sine. Why would it be sine? I mean, you could make it cosine if you shift it over. Good. Okay, so the cosine wave starts at 0, 1, right? Whereas sine starts at 0, 0, right? So you know how the midline, it goes through 0, 0. So I would use sine in this case right here. All right. What would the amplitude be? Not, it would be 2, right? Because from the midline to the top of the wave, it's 2. All right. What would the period be? So this one, because there's no value, there's no like x values, or you don't have like pi over 2 here, or like pi, you don't have those values kind of thing. I will accept like any value for period on this one. Okay, because especially because there's no value there. Okay, so if you put like 4 pi, 3 pi, that's fine with me. Okay, and then you may have to like put in some value here. So if you have like this right here, if you put in a value here, if you put like 2 pi here, then that's fine. Okay, so just be mindful of that. I just want to see you guys think a little bit in this situation. Okay, so if you put 2 pi, and then what would you do? It'd be plus 5 after that. You could really put any number here, that's fine. But for me, it's just, I want to see the plus 5 and the 2 right here. That's what I'm looking for. Okay,
How do you know that amplitude is two?
because remember the midline right here? Here's the midline right here, right? That's the middle of the wave. It's how high it goes from the midline. That's the amplitude. Or how low it goes from the midline. All right. Cool. All right, here we go, almost there. All right, the general graphs for all 6 functions, you guys kind of know this. If I could get like, I'll give you more graph paper if you need it, okay? Especially with these graphs. But if you can kind of make sure you're accurate with like sine and cosine, like maybe you might want to put cosine theta and secant theta together, right? Because what, this would go here, 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 and here. And make sure you draw both sides here. Right? Yeah, let's just say this is 1. Okay, so, and then the secant would be right here, right? All right, and so what? It would be going this way and going this way. And remember for secant and cosecant, the period is 2 pi, even though the asymptotes are separated by 1 pi, right? Because one parabola is kind of going up and the other is going down. So the full period is 2 pi on secant and cosecant. For cotangent and tangent, just 1 pi. All right, so just be careful with that. The blue is a secant. I should probably do that. Cool. All right, and then for tangent and cotangent, you got to be a little careful. All right, because for tangent, we notice what? It's this and this, right? And we did something like this right here, right? Thank you. All right. But remember that when you do what you call it, cotangent, it's going to be shifted a little bit. I'll do it here. The asymptotes are going to be here, starting at 0, pi, 2 pi, and it's going to be going this way. All right. Okay, so the red is cotangent, the blue is tangent. Okay, so just be mindful of those. But just try to, again, they're trying to get the general shape here. That's it.
On secant is the asymptote for every time it's CX.
Yeah, correct. Because when you flip it over, right, it becomes undefined, right? Cool. Oops, wait, hold on a second. I messed up on the last one. The asymptote is right here, right? It looked kind of weird. So now it's here. Yeah. All right. And then sine is pretty much, you guys want to do that together? We can, but I think you guys are fine with that. Okay. Sine is the same thing as cosine, is just shifted over. So for sure, asymptotes, I just want the asymptotes and then just give me the general figure from there. Okay. All right. I just want the asymptotes from there. So sine would be, if you did sine, let me erase this actually. Sine would be here, here, and here. And this is 1 right here. Here, here, here. So sine would be here. Cosecant would be this right here. I would practice this, okay? It may look easy, but just there might be some things that you get stuck on. So, yeah. All right. I'll be out of my 40 minutes in Zoom. So, all right. Here we go. Next one is 3 sine x plus 2. All right. I would just graph 3 sine x and then just say that you're shifting it up 2. Okay, so the amplitude is 3, period is 2 pi. All right, because the b is 2 pi. All right, so 3, so if I go here, 3. Okay, so this is 3 sine 2 x plus 2. All right, and then just shift it up. You know, if I were you, maybe just do this. And just say plus 2. Remember that if I put a different period here, like if I put like a 4 here, remember it's squeezed in. All right, so just be mindful of that. Right. Or number 2 or letter B. You guys good with this? You guys can watch it on video. All right. Cosine 2x, remember, so it's 2 pi over 2, which is pi. So our period is pi. Our amplitude is 1. So let's just say this is 1 right here. This is -1. And then remember, the full period has to go till pi. So it would be right here, 0, up, and over. Up and over. All right. So it is, yeah, it's smushed over than the extended cosine. Cool. All right, we're getting closer and closer to the end here. That was number, what number was that? Last page. Cosecant, that one's pretty easy. We did that one just now, right? It was, yeah, you should probably graph the sine. So it was this. I'll probably give you something a little bit harder on this one. I'm going to tell you that right now. I'm probably going to give you like a transformation, and it'll probably come from the worksheet that you guys have. Okay, so you might want to graph like something like 2 cosecant, like I don't know, like 2, and then x minus like pi over 6 or something like that, you know, plus 2. Okay, so just be aware of that. Okay, that I'm probably gonna do something like that. So, all right, so if I were you, I would graph 2 sine 2x first. Why? Because again, once I get this down, right, I can just do I could just flip it over and then get the cosecant. So, remember the amplitude is 2. The period is just pi, right? So it would be pi would be right here, sine would be right here, and then 2, let's just say 2 is right here. So it would be right here. So it has to be done by then, right? So let me go back. So it would be right here, right here, right here. Because it's right here.
Oh.
So I'm doing the different equations. So. Okay. So if you graph this, right, and then like with your pencil or whatever, just say pi over 6 to the right, and then up 2. And just kind of like estimate it a little bit, that's fine with me. Okay, something like that. Yeah, it's gonna be kind of hard, but just make sure you write the shift down. Okay. Cool. And then cosecant 2x, just real quickly, will be, I think, I forget, it was 0, yeah, it'd be here. And then maybe we smushed here. I think it would be, what would the period be? Pi. So the first part would be here. And then it would be here. Okay, so it's just gonna happen more frequently. Pi. All right, cool. All right, that was a long one.